We'll do calculus first. Let's do calculus first. Okay. Okay, let's start from the beginning. Let's find out where are all the calculus questions. Okay, question 1 is calculus. Now, I need to remind you that you must know a few things. So what are average variable cost? Then of course, the other one that is variable cost, average variable cost, all this need to know what they are. And then the other thing that test here is, of course, your total cost is equals to variable cost plus fixed cost. Okay, so cost. So when you talk about cost function, please know what they are. Other than that, they are not difficult. Okay, okay, I shouldn't say it's not difficult all the time. Next year, you'll complain again. All right, come, let's write down. Now, let's have a habit of telling them what you're writing. Don't write a lot of short forms. Okay, don't write a lot of short forms. If you want to write short form, just write at least write one time first. The full name that you want to do. So this is your fixed cost. So fixed cost is 10 according to the question. Then we have the AVC. Now, this is the average variable cost. So we call this the AVC. AVC is Q squared plus 4. Now, average you must divide by total quantity. So this also tells you that this is your variable cost divided by the quantity, okay? Which gives you this. So your variable cost will work out to be QQ plus 4Q. Okay, so now we are ready. We're ready to find your total cost. So the total cost, the TC, so this is the total cost. Plus this 10. Okay, so up to this stage, we found the total cost. So we're going to work our way to profit. To find profit, we still need one more thing, the total revenue. What is total revenue? Total revenue is your price times quantity. The price multiplied by how many you sell, okay? So from the demand function, the demand function, you get P plus Q equals to 20. So question asks us to determine the profit function in terms of Q. Okay, so we get P equals to 20 minus Q. So now total revenue. Let's look for our total revenue. So PQ. Now this will give us 20Q minus Q squared. Okay, so with this, sorry, wrong. With this and this, let's look for our profit. Now, profit usually in the syllabus, they use pi, so we just use pi. So profit equals to total revenue minus the total cost. Total revenue. Okay, minus the total cost. Okay, there's only one term to simplify. So let's simplify and then let's reorder the powers of Q. Okay, so this is the first part that we need to reach the profit function in terms of Q. So the next part, we're going to use calculus to differentiation to find the value of Q that maximize the profit. Okay, so the two things you need to do. First, you need to find the stationary point. The next thing you need to show that it really maximizes the profit. So first order derivative, second order derivative. So let's start with first order. Okay, so we set this to 0. Now, once you set to 0, you get 3Q squared plus 2Q minus 16 equals 0. Okay, factorize this. Plus 8. Okay, so Q is equals to 2. So this one reject. So we found the production level. Now we need to confirm. So to confirm that this gives us maximum, let's find our second order derivative. Now this one, if you put Q inside, sure negative one. Okay, so this is less than 0. So therefore, profit is maximized. Q equals to 2. So up to this part, any question? This is fairly routine. It tests your knowledge of cost functions. So all the various cost functions that you need to know. So up to this part is fairly routine. Now the not so routine part is they ask you to sketch the graph. Hang on, let me go up to the top. Okay, okay, let me go up to the top and talk about this question. So this part all done. Now this one. It says sketch a graph of the derivative of the profit function. So they purposely put italic for this word is because they want you to sketch this one. Okay, they want you to sketch this. So come, let's capture this. Okay. Okay, so in order to sketch this, I'm going to let it be a function. I'm going to give the name a function. I don't like to use this profit function. Yeah. You can use continue to, you can continue to call it, as a profit function, but I'm just going to rename it, okay? I'm going to call it G, or you can call it F equals to this. So now I'm going to just sketch it as a graph. So we want to sketch it for Q greater than or equals to 0. So treat it as a graph. Don't confuse yourself. Just treat it as a quadratic graph. So the quadratic graph, this graph will look like, it's looking like this. Okay, set face. It's a set face, but we need to take care of the portion from Q more than or equals to 0. So a few things you need to know when you sketch graph, you need the intercepts. Okay, so you need the intercept. So when Q is 0, then this is 16. Then the other part where we found, right, when this is equals to 0, when this is equals to 0, we got two intercept. So Q is equals to 2. Okay. Then the other one we rejected. So now we need to find a yeah, that's all we need. Usually we still need to find the maximum point. Where is it? But the maximum point occur in the negative part. So this graph, wait, okay. Just going to look something like this. Okay, this is your Q. This is your G of Q. Now this is 2. This is 0. The part that you're not supposed to draw is this part where there's a maximum point, and then it goes like that, the other side. Okay, the maximum point occur a little bit behind here. Okay, so this part no need. Okay, so label this point 16. So they only need to see this point, and then your axis, then done. The end. Okay, so very simple, quick sketch of this graph. Just don't confuse yourself. This part where it cuts it at 2, because this is the derivative. At 2, right, is a stationary point. The gradient is 0. That's why it cuts the axis. Okay? Right? Okay. So we are done. One question down. Okay? Yeah, okay. All right. Let me see which one. We're going to skip question 2 first. Question 3 skip also. Okay, let's go to question 4. Lagrange. This one. Sorry. Just not accidentally deleted. Now use the Lagrange multiplier method to find the minimum value. Now for two variable calculus, we don't need to prove the maximum minimum. We just need to find, and then the value that we get will be according to what they say. If it's maximum, minimum, then minimum. So over here, they wanted us to use the method. So they already very specifically tell you who is the function and who is the constraint. Okay. The minimum value of the 1 over x plus 1 over 4y, that one is your objective function satisfying positive values. So positive value, x plus y equals to 12. Can you set up the Lagrange? Let me see your Lagrange. Lagrange is important because you do a few times of Lagrange multiplier. That some of you are not worried. Some of you are very what to do. Okay. Set up the Lagrange. Set up the Lagrange. Don't just wait for me. You have to set up. see of some of you writing the way that's for differentiation. Very good. Set up the Lagrangian, the Lagrange multiplier. Post one more paper inside so that those people all done actually can do another. Okay, the branch. Must give the function a name of, put a capital L, then X, Y, lambda. Yeah, I walk around, a lot of you don't know how to set up this. You don't leave this to the last minute, because this part they test a lot of Lagrange multiplier. Okay, come, let's do that. So now normally I'll put the problem there, okay? So the problem is to minimize this function subject to okay, so the Lagrangian now the Lagrangian, you give it a name, so xy lambda. Now I want you to write it this way, can? So that you can differentiate it easier. Yeah. Do it like that. So that's a Lagrangian, and then we differentiate. Okay, with partial with x minus 1. Sorry, just minus will do a negative x y gone minus lambda equals to, set it to 0, then straight away write down what is this lambda. Your lambda is equals to negative 1 over x squared. So that's one of them. Okay, the next one. Negative 1/4. So this lambda is equals to negative 1 over 4y squared. Okay, so we have equation 1, equation 2. So the one with lambda now, set it to 0, return the constraint. So over here, either you divide or you set them equal to each other. I'm going to set them equals to each other this time. Easier to set them to each other. So let 1 equals to 2. Then we get, so you get this very nice expression. 1 over x equals to 1 over 4y squared. So just take the reciprocal, flip them up. And because the question says positive x and y, we just take square root, no need plus minus. Can? We just take square root. Otherwise, right, if this statement is not there, you need to consider plus minus. But this statement is there. Once I take square root, I'll get x equals to 2y. Okay, and then I'll just say that your xy more than 0 lah. Okay, xy more than 0 based on the statement above. This part. Okay, so this is equation 4. So you put 4 back into Number 3. So you get 3y equals to 12. Your y is equals to how many? 4. Then the x is equals to 8. So now we need to calculate the minimum value. So minimum value, you get 1 over x, 1 over x, 1 over 8 plus 1 over 4 times 4. So this should give you over 8 plus 1 over 16. So this is equals to 3 over 16. Okay, and then that's it. We're done. Can? So this is a standard Lagrange multiplier question, constraint optimization. So you get a constraint, and then you need to find what is the optimal value. Any question with this? Any question? How? All good? Okay, so I must know how to do this because this kind of question will appear in different pattern in different ways. Okay, number 4. Let's look for the next calculus question. Number 5 also calculus question. Okay, all done here. Okay, number 5. Now this looks like so difficult. It's not. It's just reading only. It's a 2-variable application question. Now, once they give you application question, the maths behind it is not very difficult. Usually with application, they're not testing you the maths, just a little bit of the maths, but more to how you apply. I think I did only one question in a lecture so far. So this is the other time that you see this type of question. So if you read through the question, you'll know that this is a question that you have to determine profit, okay? Maximum profit. So the idea of profit don't change one, whether it's 1 variable or 2 variable. So idea of profit is still total revenue minus total cost. Now that you have good X and good Y, your total revenue comes from the total revenue of X plus the total revenue of Y. That's the only difference. Okay, then the total cost function they give you already, so you don't have to bother. Okay, so let's do the part where we structure it and then we find out what is our total revenue and what's our total cost. Okay, then we can find our profit. Okay, you all got the question right now. Okay, so now come, we have demand. Now you can put the X and then the Y. Okay, we find them separate, then we combine. So given the demand, earlier on we are told that this is the one. So therefore your PX is equals to this. Then for the Y, the demand is this one. So your PY. So that's demand. Now we calculate the individual revenue. So the revenue. So for the X, the total revenue from the X is PX multiplied by the quantity of X. So here they say quantity is X, so we follow. So this structure don't differ too much from your econs also. So PXX, PYY plus PYY lah. Okay, and then this one we get so now this one total revenue of Y. Y square. Okay. So now we have the respective revenue. We can now find total revenue. Wait. This one is total revenue. So tell them we're going to sum both together. Okay, our total cost is given on top. So the total cost is given as x squared plus 2xy plus 20. Okay, time for you to work. Write down the profit function. Write down the profit function. Then after that, I want you to try to optimize it. Okay, so this is a two variable optimization. We are going for profit maximization. So number one, find the X and Y quantity that maximize the profit. Number two, prove that it is maximum. So you need to get your Hessian, the pi XX and the pi YY and the pi XY. Okay, so the profit so this is total revenue minus total cost. Okay, come, you all do a little bit. Do a little bit of total revenue. So I'm just rewriting all the terms and then I'm going to subtract. Okay, so this should be your profit function. So we're going to take a partial derivative with respect to x, then with respect to y. Then we can set them to 0, and then we find, let's see what we get first. X minus 2y. Okay, set this to 0. So we're going to get 3x plus 2y equals to 100. So equation 1. Okay, the next partial derivative. 100 minus 4y. Set it to 0. This one we get 2x plus 4y equals to 100. Okay, so I'm going to do substitution. So I'm going to simplify this equation. So we get x plus 2. So this is equation 2. Okay, let's solve. Hmm. So this one is 12.5, or you can put 25 over 2. And your x. So substitute back to here. You get 25. Okay, so we found the x and y. Now we need to confirm that it gives us maximum. Okay. So to confirm that it gives us maximum, we're going to take the partial derivative of this one more time. The second order partial derivatives. Okay, so the pi xx is minus 3. The pi yy is minus 4. The cross derivative is what's the cross derivative? Take 1, get minus 2. Yeah, okay. Let's see, positive. Okay, so since now this value, right? This is your Hessian. Is positive or negative? Positive? Positive, huh? Okay. Once it's positive, you have to check this one. This pi xx. So this is less than 0. So this confirms that our profit is maximized. Okay, so 25 y equals 12.5. Okay, so that's the standard part that is being tested. Okay, so we concluded the whole part where we find the quantity. So now the question says, purposely one, the question purposely. Suppose now the firm is required to produce equal amount of x and y. Okay, equal amount. So this translate to mathematics is the small x equals to small y. Okay, because the quantity need to be equal. So over here, the one that we need to take care of is over here, your revenue function, because now is the situation where you do x equals to y. So you change everything to x or you change everything to y. Then you do differentiation again. That's the statement. That's what the statement is trying to say. A equal quantity. Produce equal quantity. Okay? But if you have done like everything, you should have passed the question already. So up to this part should be enough to pass the question with quite good marks already. So now let's take this statement. They produce quantity that are equal. Okay, when the firm equal quantity. Then x is equals to y. Okay. So our profit function. You have a choice. I chose to change everything to X. Okay, I chose to change everything to X. You can do everything in Y. I'll do everything in X. You can try to do everything in Y. And then after that, and see whether we get the same answer or not. So this is changing all the original. Wait, okay, I don't have the original. Now this term was originally Y. This term was, I think, 2xy, I think. Yeah, then this term was Y square. So now I change it all to X. Okay, simplify. So you should get negative 4, 5.5 square. Okay. So let's differentiate and set to 0. So just set this, the derivative to 0. You should get minus 11x plus 200. Okay, so x is equals to this. And then because x is equals to y, your y will be also equals to the same value. So we're left with one last thing. We need to check that with this combination, it also maximizes the profit. So we need to find the second derivative. Should give you negative 11. Okay, so therefore, maximize. So with these two quantity. Okay, so that's the end of the question. You'll feel that the flavor from last week and this week, the questions, the flavor a bit different, huh? Okay, the flavor is quite different, huh? But generally there's still quite a number of partial differentiation. So you must really know your partial differentiation. Okay, you can move on to the next one. Question 6, also partial differentiation. Okay, so for those who are done, oh, sorry, my screen still frozen. Okay, sorry, if my screen don't move, you must tell me, okay? See that. Okay, let's go to this. The aim of this question, now this question, either they ask you to find this, or they'll ask you to find x or something times the second order partial derivative. Okay, so in previous question in front, we already done like quite many partial derivative. So still partial derivative. So over here now, the thing that they test is exponential function. Okay, we need to prove this. We need to prove this. This question, if you're steady inside your partial differentiation, this question is not difficult. Okay, so except you now have to deal with exponential function. So you can find them first. Can you find these two quantity? The x1 is easier than the y1. Okay, the partial derivative with respect to x is easier. The partial derivative respect to y is harder. Why harder? Why is the one with respect to y harder? What do you have to use for the y? Don't you have to use product rule lah? The one with x only. The one with y you have to use product rule. Because with x, y is a constant. But with the partial derivative with respect to y, y is y plus something e to the power of y squared. You don't remember the first time I teach you this, you treat some of them as a constant, right? Then who is constant, who is variable? Now I don't write all this now because I suppose you know what to do. Okay, so let's differentiate with respect to x. Now this term is this. They are equivalent, okay? I don't like to write this because very cumbersome. A lot of things to write. So now come, let's find this. So if you differentiate with respect to x, this is the only variable, y is a constant, so constant stays there. Write the exponential function. Yeah, this one very hard to write, sorry. Okay, I'm going to write it this way this time. Okay, so then differentiate. X squared become 2x. Then this one, the y square is a constant, so nothing to do. Okay, so you simplify it. You should get 2x. Then the y cancels off with one of the y's inside. So you get 2x. Okay, so now the next one is harder. So this one, let's see how. So we want to use product rule now. So y is the variable. So I'm going to maybe help myself with something is, maybe it's better to write it like that. Because in this way, we can differentiate it better. Okay? So I brought the power up, I brought the y square up to the numerator. Okay, so keep the y, differentiate the exponential function. So write this term first. Okay, differentiate the power. Now, x squared is constant, so put the x squared there. Bring down the -2, then y -3. Okay, that's done. Plus the exponential term, and then multiply by 1. So this term is the complicated looking one. Okay, let's simplify it slowly. Okay, I can return this to the form already. Don't need it to be. Then let's see what's inside. -2x squared over y cubed. And plus this. Now we have common factor. So this term is common factor. So let's bring, you can bring it out if you want. I'm going to bring it out. So e to the y cancels off. So we get negative 2x squared over y squared. Then plus 1. Okay. Okay, so we are ready now. We are ready. We have this term. We have this term. So now we need to calculate this value. Okay, we need to calculate this value. So I'm going to multiply x to this term. So I get 2x squared e to the x squared y squared over y. I'm going to multiply y to this term. Okay, multiply y to this. Okay, I'm gonna just put it outside first. Huh? Hmm. Okay. So what I need to get back, we just need to keep focus. We need to get back this term. We need to get back this one. Okay, so let's see when we write, we get back or not. Okay. There's a common factor, we can take it out. Let's take out the common factor first. Okay, so here is left with 2x squared over y. Then you multiply this y inside. Multiply this y inside. So you get negative 2x squared. Now, cancel off 1 over y in the denominator, then plus y. So this two term will cancel off. And then you get back y times this, which is what you want. Y times this. And this is this. Okay, so then we tell them this is your f of xy. Okay. So this is just a pure mathematical exercise. Just mathematics. Okay, we're going to do 2 more questions before we go for a break. If you're done, just go on to 7B and 7C. Okay? We're going on to 7B and 7C. So all partial differentiation. You can start off first. You should start off. I want to look at what you'll do. Okay, start off, please. For those who are done, start off. Yeah. Okay, I see a problem. Okay. Okay, Bill, when I write wrongly, you must tell me. Sorry. This term, this don't have an E there. Okay, don't have the E there. Y multiply. It should be Y multiplied to this. Okay, sorry. This one not correct. Come correct this, correct this. It's just x squared, y squared. Yeah. Okay. Can I please correct that? All right, come, let's go to 7B now. So by moving around all of you, then I find some problems. Now you can differentiate all the partial derivative first. Now, what's the advantage of differentiating and getting all the partial derivative, the first order and the second order? What's the advantage? You will know whether your first order is correct or not. Because when you do the cross derivative, they are supposed to be the same. If your first order is wrong, your whole question can almost get 0 already. Can? So you differentiate all the 5 of them. Can? Then technically there are 6 lah, because the last one, the f, the cross derivative f are partial xy and partial yx, they are the same. If they are not the same, you must go and check whether something is wrong. Huh? Okay, come, let's differentiate everybody lah. Okay, so this one is, okay, now this one. Okay, let's find its partner, the second order. Get negative 6x. You get 6y. Right, you should get 6y, right? Okay, then check. Now let's check the f, this one. Okay, so you take either one and differentiate. So you use the x1, you differentiate respect to y. You should get -2. Okay, then you don't need to do the other one, but you can actually check. So you can actually check the other one. So this one. Okay, differentiate with respect to x. You also get -2. Stress to you all again, this 2 must be correct. This 2 not correct, no need to do the question already. Okay. Okay, so the next part is we set them to 0. So set them to 0. Now, once you set it to 0, you will get 3x squared plus 2y equals to 0. And then the other one is, the other one you get is 3y squared minus 2x equals to 0. So you have these two, right? You notice that one of them have a y. You can express, either you make y the subject or make x the subject. Try not to handle the square. The square and the cube unfriendly one. So the one that has no power, only power 1 is better. So I'm going to work from here. So I'm going to have x is equals to 3 over 2y squared. Okay, so equation 1, equation 2. So sub 2 into 1. So when you sub 2 into 1, you get 3. Just be careful. This one need to square. Earlier on when I did the question, I also forget to square. So you get 27 over 4 y squared plus 2y equals to 0. Then multiply by 4 throughout, you should get 27. Sorry. Wait. Here supposed to be power 4, I think. Wait. Power 4. Then you get plus 8y. Okay, so factor out the common factor, which is y. Factor this out, then you get what you need. So you get y equals 0, or y cubed is equals to negative 8 over 27. Very nice number, perfect cubes. So your y is equals to negative 2/3. Okay, so our x is this. So we just put the value back to here. So the x is equals to 0, or the x is equals to 3 over 2, negative 2 over 3, whole thing square. And this also gives you, I think, 2 over 3. Okay, so we found the stationary point as what they say. This one. So just confirm with them. Therefore, 0, 0, and 2/3, comma, minus 2/3 are stationary points. Now, they never ask us to find all of them. So they only ask us to do this. Then we just do one. Huh? By right, we should do both. So let's take this Porsche. Oops, sorry. Let's take this one. Okay. Okay, so we just calculate the value. So the Hessian, now if you have a lot of them, do a table, okay? If you only one, just do that one. The Hessian, the h of xy, this equals to minus 36 xy minus how many? 4. 4. Is it minus 4? Minus 4. Okay, so this h of 0, 0 is just negative 4, which is less than 0. So this one will tell you that 0, 0 is once it's negative, don't need to think so much already. It's a saddle point. Okay. Now this question 100% will appear on 100%. To find stationary point, and this is called unconstrained optimization. So this after this, the Lagrange is the constraint. So this is unconstrained. Okay. Now the next one is a little bit more challenging. Actually, I don't know what's the extent, or they want us to show that this is the stationary point. Usually to show, we have to find. But in the exam report, right, after they take the partial derivative, then they say, yeah, 0, 0 is the point, is the saddle, is the point. Okay, 0, 0 is the critical point. Okay, so I'm going to do the whole differentiation, and then I'm going to solve the equation. Okay. So come, let's find the two partial derivative we'll do. Now, this type of question don't usually come out in your exam. This type of question usually come out for Maths 2. So this one, when they ask you to do something like this, is to consider directions. Okay, you take all the, here fxx, right, is to consider all the x pairs. X, yeah, all the x pairs. So your x is 2, your y is also equals to x. This is telling you consider all the xy pair that are equal. That's why this is xx, y equals to x. Otherwise, this is xy. So this is a notation of writing f of x. Then this one is y equals to x. So all the xy pairs, all the xy pairs, they are equal. Okay. All right. Now, let's find the partial derivative with respect to x. You get this. With respect to y, you will get this. So you notice they are mirror image of each other. Hey, wait, hang on. Forgot, still got one more term. respect to y, right? Y, then plus 3y squared. Okay, so I'm going to set both of them to 0. Now, this one equals to 0. We get y 2x plus how many? Y equals to 0. So y equals to 0 or y equals to negative 2x. Okay, so now this one equals to 0. You get x squared plus 2xy plus 3y squared equals to 0. So let's put in our y equals to 0. So when you get x squared equals to 0. So x equals to 0 when y equals to minus 2x. You get 4x squared minus 4x squared plus 3 multiplied by minus 2x squared. Okay, minus 2x, whole thing squared. Okay, so one look at this, you'll get this one cancels off. You get x equals to 0 again. So x equals to 0. All right, so if x equals to 0, you put it back to here, the y also equals to 0. So y equals to 0. So conclusion, only 0, 0. Okay, 0, 0 is the only only stationary point. So 0, 0 is the only critical point or stationary point. So now we take the hint. They say you might find it useful to consider the values of fxx. So first, we consider our value of f of 0, 0 first. Now, this is only critical point. Only critical point. Now, first of all, we consider this value because this value is a critical point. So we need to consider f of 0, 0. Okay, this is equals to 0. Now, then we consider f x comma x. Now, if you consider f x comma x, you change everything to x. So you should get okay, let me write down first. You should actually get this term x cubed plus x cubed plus x cubed. You should get this term. So you get this term 3x cubed. Okay. So do you know how to make sense of this? That function, now we are taking all the coordinate along the line y equals to x. So the y equals to x, right? You'll see a quadratic, no, not quadratic, a cubic function. Do you all know how this cubic function looks like? Sec 3, this one Sec 3 mathematics. How this function look like? X cubed. The 3 is just multiplied by 3. How does x cubed look like? Okay, x cubed, x cubed, the graph looks like this. Oh, sorry, curve too much. It looks something like this. Yes? So you also know that if it's in one dimension, it's a point of inflection. So over here now, we're going to prove that it is a saddle point. A saddle point is you look from one orientation is going up, you look from another orientation is going down, minimum. Remember, saddle point, right? So one orientation looks like this, another orientation looks like that. Okay? All right. So then what to do? You take all the x pairs. So you take the x that is a little bit bigger than this. So we say when x is more than 0, Am I right to say that your f of x and x is more than your f of 0, 0? Correct. You think about it, I'm taking, because you take the value of x equals to 0, 0, you already found this already. Now I'm taking x more than 0. X more than 0. So it's bigger than this. And then because it's x and x, so both of them are bigger than 0. So this value must be bigger than this. Higher than it, right? Make sense or not to you? Number. Make sense, Makes serious, make sense, because some of the face don't make sense. So let me write down this statement, then you think about it. Hence, your 0, 0 is not a local maximum. Why not local maximum? Because a value is higher than it. Your f of xx is higher than it when you take x more than 0. So this point 0, 0 is there. You take a little bit higher, it goes higher. So this point, right, cannot be a maximum because there's something higher than it. This point cannot be a maximum. So now we're going to show that it is also not a minimum. So now we take the other side. When x is less than 0. So think about this. What's the value of this? Less? Is it less than the f of 0, 0? This is your stationary point. We are looking at the area around the stationary point, above and below. The stationary point, we are looking at places above and places below. Okay? So over here, we also can say that hence your 0, 0 is not a local minimum. So if it's also not a local maximum, not a local minimum, we exclude both of them, they only left with one more choice, which is a saddle point. Okay, so this how do you have to argue this? Therefore, 0, 0 is a saddle point because it's not max, not min, so it must be saddle point. Can? Must go back and digest this. You just think about, because you found 0, 0 is a stationary point. Now you look around the area. You look around the area. Then the area nicely, that curve, right, is a cubic curve. So you look a little bit to the left, a little bit to the right. This is telling you to look a little bit to the right, a little bit to the left. Same as your one variable, right? You look a bit a bit forward, a little bit backward, then you see what happens. Okay. Okay, so this is this. Now is a good time for break. Let's go for 10 minutes break and then we come back again. Okay, let's go for 10 minutes break. Let's come back at 5. Okay, 1, 2 p.m. Okay, go for your break. Hello, hello. We still have one very long question at the end. Okay, hang on. It should be yeah, let's do the last question. Then we'll finish everything differentiation. This is the last differentiation question. This one. So this is the highlight of this paper. Okay. From the beginning until this part, it is fairly standard. So then now the challenge is whether your mathematics can cope with what they want or not. All right. Okay, let's read the question. You have a production function. So this is a production function. So this is the irritating part where they say it's in A. Then your A. Now this one is important. Later. Your A is between 0 to half. So K is the number of amount of capital. L is the amount of label. Then the capital and the label costs are listed here. So standard setup didn't change from econs. Okay. VK plus WL. So the VK plus WL will be your cost. So now they want to show that the minimum amount that the firm can spend. So I know some of you got problem finding out who is the objective function and then which one is the constraint, okay? So now we want to show the minimum amount. So we're going to minimize cost. We're going to minimize the cost function. Subjected, the constraint must be the quantity, production. So subjected, show that the minimum amount that the firm can spend in a week on capital and labor if it manufactures a total amount of Q. So we want to minimize the cost subjected to this production Q. So the problem will be, wait. Now the problem is to minimize your W, sorry, let me check. VK plus WL. Capital V, small k plus WL subject to this KA, L power A equals to Q. Okay, so you minimize the cost subject to the production. Can identify, must make sure your Lagrangian write correctly, because your Lagrangian wrong, the end, this whole question no need to do already. So come the Lagrangian. Can you write your Lagrangian? The Lagrangian is L, capital L, K, L, lambda. Okay, 30 seconds. You write yours first. You write yours first. Okay, let's see what you're right. Okay, almost 30 seconds. Okay, so this is the one. Okay, go ahead, differentiate first. I want to take a look at what you do. You need to find all three of them. Either you set it to 0 immediately or set it to 0. You set it to 0 and quickly solve, because the solving is a little bit harder to find the value of K and value of L. People ask you differentiate with respect to K or L, This product term, this product term, the other fellow is a constant. Constant don't take part in differentiation. Okay, let me differentiate one to you and then I'll tell you what. Okay, the other thing is notation. Please don't write this. This is different from how we look at your FX. Different notation. If you look at the examiner's report, right, they don't write this. So you don't write something to confuse the examiner. Okay, so if you want to write that way, you write it this way, or the other accepted way is you partial L over partial K. Okay, so both of this accepted. Just not the just not this, this one. Not this, because different way of writing. Okay. So come, with respect to K, you should get V minus, now you get lambda K, right? A, then K, A to the minus 1. Now your L should stay. L is a constant. L to the power A is a constant when K is the variable. Okay, it should be here. Okay, so set it to 0 and then you can, your V is equals to this. You'll turn out something very beautiful one. Although it looks so ugly here. Okay, so the next one. Okay, so this one W equals. Okay, so the last one, let's back to lambda. So return the constraint. So we have equation 1, equation 2, and then equation 3. Okay, so this 1, 2, and 3. Now, my favorite is take 1 divided by 2 or 2 divided by 1 over here. Because this will give you back very nice numbers. Okay, so I'm going to take 1 divided by 2. So let me write everything there. Lambda, I don't know, this one. Okay, I write everything first because I'll show you what to cancel. Now, this cancels. So now you need to know where to move this to. Your K, A to the minus 1 power. And then this one, your power, right? So let's take, for example, the one with this one. So I'm going to move this up. So this says, indices law says same base, different power, you divide, right? You're going to take minus away this. So this will become L to the power 1. So I move it up. Then for this, I will move it down. The smaller power goes to where the bigger power is. Okay? So you should get this. L and K. Can? So your L is VK over W. This is your L. So this will be your equation 4. Okay or not? In getting this, you bound to get this. Should get this. They rarely give you weird stuff. They do, not so regular. You bound to get this. Then if it's a utility function, right, you'll get Px times Qy or Px times Pxx Qyy. It's always like that one. You get something very nice one. Okay. All right. So with this, we're going to put it back to here. This is the part that is going to be challenging now. You put it back to here. Okay. So you take a few seconds. Maybe 2 minutes. You try to settle this. So substitute 4 back to 3. Okay, so we get substitute 4 back to 3. We're going to get k to the power a. Then this whole thing to the power a also. Okay, equals to q. All right, so we need to find what is k. So your end result is k equals something. Okay, I'll struggle with this for a while. So extract the k out. So k to the a multiplied by k to the power a, you get k to the 2a. Now this one, just stay as it is first. Don't move. Okay, so all power a. Okay, then k to the 2a is equals to divide this away to the other side. So if you divide, it will turn itself. Can? Or you can think of it as multiply term by term. Okay, so now here comes this. You need to multiply by, you need to take the root, this root, the root of 2a. So what I mean is you need to think about how to do this. This, wait. You need to multiply it by this power. So on both sides. So you can get rid of the 2a. Then you get k equals. Okay, what do you get? So you should get this one, power half. Then this q, right, have 1 to the 2a. Okay, so power half is square root. So you can also say that your this term you rewrite it as root. Okay, so this is the optimal k. Now we need to find w. So this is the one. So you're going to put the k back to here. Put the k inside. You put it in a way that you can understand how to simplify. Put it into here. Okay. So if I make it smaller a bit so I can see. So L. So you put the VW like this, can? Then the K is just outside. So you just put the term here. So then nicely cancels off. This can cancel with this can cancel with that. So your L will be V over W. V over W, Q to the 1 over 2A. Okay, so we got them already. So we need to calculate the minimum cost. Okay, you calculate the minimum cost. Calculate the minimum cost. Your minimum cost, you need to show. You need to show that your minimum cost is this. This one. You need to show. Okay, so come, 1 minute, you all do the minimum cost. VK plus WL, the minimum cost. Minimum cost is equals to your VK plus WL. Okay, we need to show that. Okay, y'all do first, y'all do. Try it. See whether you can get the answer or not. Correct? VK plus WL, right? It looks difficult. Only look only. The actual thing not difficult. This thing can cancel. This one can cancel. This one can cancel. Okay, so let me take out this one first. This is common factor, so I put outside first. Okay, I'm going to do the cancelling inside. Now, V divided by root V, you get root V. Okay, so you get root V multiplied by root W. And this one, you get root W multiplied by root V. Okay, so indices law, different base, same power, you can product them together, okay? So if they are the same, right? That's why you have two pieces of them. So this leads us to the answer, 2 root VW. Q, 1 over 2A. So shown. Yay. Okay. This question is at the last question. I will say this paper, you should have enough time to reach the last question. Last week, that paper, right? To reach the last question, maybe a bit difficult. Last week, that paper is difficult. This paper is only got certain parts which are harder. Generally manageable, this paper. But last week, that one is a crazy one. Last week, that paper. Okay? So this year, your year belong to the last week paper type. Yeah, because your maths one is easy, hard, easy, hard, easy, hard, alternate one. Okay, so this year is, you all better prepare. If it comes out easy, good. If it comes out hard, that means you're prepared. At least you won't go in and cry. Okay, now let's do the last part. What's the last part? Okay, the last part is, so you read, okay, you read the last paragraph. The last paragraph, if you already reached this point and you want to give up, just give up. But if you don't want, come read. Let's read the last part. You ask yourself, what are they testing? What do they want you to find? What do they want you to find? You must understand what do they want you to find, then you can do this question. You have done this like 2 or 3 times in the front. Same thing. You've done this just now 2 times, right? One for one variable, one for 2 variable, right? You did it twice just now in front. So in order to do this question, what must you gather? You must get total revenue, total cost, then find profit function, differentiate first time, set it to 0, differentiate second time, show its maximum. Correct? The steps are the same. So then the problem now is, where are all the values? Your PQ, your total revenue, your total cost. So that's the part which is a little bit harder here. Okay, so now the product is sold at a fixed price P. So you got the price. What is the revenue then? Revenue equals to price times quantity, right? So price is this. Quantity where? Nah. This one. So you got total revenue already. So then where is the total cost? Where's the total cost? So the total cost is, you want to minimize the cost. So this is the total cost. And then they say something, the raw material produced each unit is C. So 1 unit cost C. How many did you produce? Q. So you need to take C times Q. Part of the cost with the raw material, and then this is the label. This is for the raw material. This is for the label and capital, the label and the machines. So total cost will be this times this plus this. There's no fixed cost inside this. Normally we have variable cost and fixed cost, but over here don't have fixed cost. Okay, so we got all our information ready. Revenue, P times Q. Total revenue, total cost, C times Q, plus with your label and capital charges, the cost. Okay, so this part is the one that is a little bit strange, because now we don't have numbers. If you have numbers, this is not so strange. Okay, so come, let's write it down. Okay, let me cut the question below. So we are doing a profit maximizing question again. So we need to find our total revenue. So total revenue is capital P multiplied by small q. So the cost, we get what we found here, plus cost of a raw material multiplied by all the quantity that you produce. So this is where you're going to start. So profit high. So you get total revenue minus total cost. So you get P, Q minus this. And minus away this one. Okay, so once you can form this, everything will be fairly easy. The problem is this. You cannot form this, cannot do. Okay, come, differentiate. Differentiate first time. Differentiate this. This is equals to P minus 2, 1, 2A. 1/2A root. Now this is Q, this power minus 1, minus C. Okay, so we set this to 0. Oh, sorry. So we need to find the Q. We set this to 0, then we get so this one simplifies already. So you get 1 over A root VM Q. This one, combine this together. So you get 1 minus 2A over 2A is equals to P plus C. Is it? Wait, no, not P plus C. Wait, what is it? P minus C, not P plus C, sorry. P minus C. Okay, continue to simplify. So Q okay, multiply the A across is A times this, P minus C, then divide by the root VM. Can? So what is Q equals to? What is Q equals to? What is Q equals to? Come. Q equals to, it's weird, like it's weird because the power is weird. This power is weird. Just take the multiply by the fraction. Multiply like what we did just now. Sorry, let me give myself some more space. Sorry, let me erase this. I give myself some space. Okay, so so do the same thing. You go and multiply with this. The power. Okay. So you power up this side with this. You need to power up the other side also. Okay, so this is our Q is equals to that huge looking thing. Sorry, wait. A so this is the Q. Does this make sense to you? This is the indices law. A to the M power up with M equals to A to the MM. Okay. You want to get power 1, you must numerator, denominator cancel off. Okay, this is not the hard part. The hard part is the second derivative. The Q is the easy part. Now we need to find the second derivative. So this one done. So now differentiate this one more time. Okay, differentiate this one more time. So cancel the 2 away. You differentiate this one more time, and then we have to argue that it is to get maximum, right? Our second derivative must be less than 0, right? So now you got no values, or you must argue correctly. Otherwise, you cannot show that it's less than 0. Okay, come second derivative. So P gone, you get negative 1 over A, then bring down that power. That power is, okay, the power, I copy this because this is the power. 1 minus 2A over 2A root VM Q to the 1 over 2A minus 2. The C also gone. Okay. Now you convince me that this is negative. You need to convince yourself this is negative. You cannot say it's negative, you have to show. You cannot bluff one. See, now all quiet already. Okay, we have a condition. We need the condition first. Given that because this part we don't need to care, but it's this part that we need to be bothered about. Given that A is between 0 and half. Okay, this is where we're going to work. Starting point. A is positive. So if A is positive, this term is already negative. So this term must be positive. If this term not positive, right, you cannot get the second derivative to be negative. These two terms, sure positive one. Because your V is positive. This is positive. Exponential term, sure positive. So then the problem now is to argue this term, question mark. This one no need so much question mark. This one is negative. But this term, how? This term must be positive. This term not positive, game over. Because we need negative. Okay? Argue lah. Argue mathematics, not argue with other people. Argue mathematics. Okay. So you just, from this inequality, you will be able to see that you need 2A, correct? So you start 2A lah. You go to 2A. So your 2A is between 0 and 1 lah. Then you need minus 1 minus 2A, right? So minus 2A is minus 1 and 0. So flip, right? You take negative, the thing flip. Then just plus 1. Wow, heng, positive. Positive divide by the denominator positive. We just need to care the numerator. Can? The steps make sense to you? Starting from here. Just argue the inequality. Then you get this numerator to be positive. Anyway, 1 minus something smaller, 2 times something less than half, sure smaller than 1. Numerator sure positive one. Okay, I'm just doing something extra to show you that this is positive. Okay? Okay, so come, given all this, therefore so now we can conclude that this is positive. The question mark can remove. So my second derivative is less than 0. And our profit is maximum. Therefore, the profit is maximized. Wait, what's the question? Maximize. Okay. Oops. When Q equals to this big chunk of thing. So this question is harder among all of them. It's the hardest already. From just now, right? We have been doing differentiation, right? You find that this demand is higher. And somewhere at the last question. Maths 1, you need some speed now. Because you only got 2 hours to do 8 questions. 6 short one, 2 long one. Okay, so we completed all the differentiation already. Let's do the series first. Because series, you all always will skip. The series question is at, okay, question 7A. This one. You see, this series question no longer is a banking application. Usually you have people save money, and then save money again. But this one don't have. This one talk about membership. Okay, so you have a membership. Now, I want to bring your attention. Okay, you read the question, but the problem with a lot of us is when to put y0 and y1. The y0, y1 is the problem. Okay, so if you look at this, find an expression in terms of n for the number of members n years after the 1st of January 12. I want you to copy that statement. So let yn, you copy the statement, denotes the number of members. Then your small n, then you just put small n, n years after, okay? After the 1st of January. You copy this statement exactly. Then you decide. I ask you now, with this statement, this first day of 2012, right? Is y0 or y1? Use this statement, please. Then look at this first day of 2012. Is it after 2012? After the 1st? After the 1st, wait, first year, right? After the n years, n years after the 1st of this. Passed already or not? The year passed already or not? This one, first day of 2012, is it n years after the 1st? In the same year, right? When is y1? Wait, okay. Y1 is number of member 1 year after the 1st of January. 1 year after the 1st of January. Then this one, how? Because the year haven't passed, right? Correct? 0 year after the 1st of January. On the first day, still in the same year. So why 0? This is the problem, because I also have this problem. Every time I look at the question, right, then I will see y0 or y1. Okay, so this statement, whenever they ask you to find the expression, you let yn, you copy exactly the statement. Copy exactly the statement. Then you decide 0 or 1, okay? So now your y0 is 1000. So then go on, y1. What is the pattern? 5% leave, grow by 30 members. Okay, so 5% leave, you get 0.95. Multiply by whatever you have, then plus 30. That's y1. Next year, next y2 now. You take 0.95 multiply by y1, then you plus 30. Okay, so then you substitute this chunk inside here. So this one gives you 0.95 square multiplied by 1000 plus 0.95 multiplied by 30, then plus 30. Usually in 3 lines, you should be able to decide what is the pattern. 3 lines. So why 3? Why 3 is 0.95 multiplied by this. Okay, so this should give you 0.95 cube multiplied by 1,000 plus and then plus 30. Can we see the pattern already? The index fairly clear. Okay, so let's go for our yn. Therefore, yn, this will be 0.95 to the n. So this index are 3 and 3. Now factor out the 30. And then after write this in reverse order. Reverse order, change it. So factor out the 30, you get 1 plus 0.95. Okay, wait, 0.95, yes. Then plus dot 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 0.95 all the way up to n minus 1. 1 plus 0.95 plus dot 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 all the way up to 1 index less. So n minus 1. Can? So then we'll tell them that this is a GP. So this is a GP. GP, we need 3 things. We need the first term, we need the common ratio, and we need the number of terms. Usually for you, the number of terms is the problem. How many terms are there? M minus 1 minus 0 plus 1. You take the last index, subtract the first index, which is 0. Then you add 1 more term in. Okay? So it's n, capital N. So this is 0.95. This is 1. Okay, sum it up. The formula is, there are 2 formulas. Now, because this is 0.95, I'm going to take the 1 minus r to the n over 1 minus r, because this r is smaller than 1. So I'm going to take this. So this one we get 0.05. So no calculator, huh? Simplify. What is 0.05? 1 divided by 0.05, what do you get? Last time in primary school, you're very good at this one. First thing, you change, you move 2 decimal place, you write it as 5 over 100, right? This one. 5 over 100 is equals to 1 over 20. Right? So you reciprocal is 30 times 20. What is 30 times 20? Okay, let's simplify this. I simplify because common factor. Huh? There's a common factor here. So you should get 400 multiplied by 4, wait, minus, yeah, 400. So the question asks, describe how the number of members behave in the long run. So long run, what do? We let n go to infinity lah. Because long run is n goes to many years. So when n approach infinity, what will happen? What will happen? Yn will approach what? This value. Okay, first of all, when n approach infinity, this value goes to where? Approach. This value is 95 over 100. It's less than 1. So once you get it bigger and bigger and bigger, you approach the 0. Because the numerator will be bigger. You try, 1,000. 1,000, of course, you don't live 1,000 years. But this one will be bigger than 95. So the denominator will be much bigger. Okay, so this approach 0. And then clearly, if this 0, this part will be gone. So the membership will stabilize. So therefore, your Yn approach 600. Okay, so the gym will always have about 600% based on the pattern that it is. Okay. Now this is a question that if you got zone A and zone B, you got 20 questions to practice inside your 10-year series. 20 questions. So the banking question, they always like to ask you what is the sum that they deposit, what is the minimum amount, the number of years that you do. So it can be harder than this. Okay. Okay, let's go to integration. Integration. Where's the integration question? Yeah, here. I just do a quick check. Your integration, how many have finished this already? Can I check with you? This question, right? What technique did you do? You did by parts. Okay. I did substitution. Anyone did substitution? This one, I don't like it when they put like that, and then we do by parts. Because by part not obvious. What did you do? Substitution? Because the by part answer and the substitute answer, like word, but very far. But I'm going to do substitution, so later we'll compare with the by parts people. So you can do by parts, it works. You can do substitution, because for me, right, when I see something like this, I will attempt with substitution first and see whether my substitution can change the integral. Reminder is whatever you do and you get something harder, you're on the wrong track. You must do something and it gets easier. You only got 3 techniques: by parts, partial fractions, and substitution. Only got 3 techniques. Okay, so come, first one. Okay, I'm going to let my substitution be the term inside the bracket. So let u equals to x plus 2. So my x is equals to u minus 2. So I differentiate this. Okay, so this is what we get. So this is equals to, come put everything in. X is u minus 2. Then this term is u to the 7 over 2. So dx, du. So you see, with this, it comes to like that. Then it's good. Because this one we can expand now. This is u to the power 9 over 2. minus 2u to the 7 over 2. Okay, du. Okay, let's integrate. You get 2 over 11 u to the power 11 over 2 minus 2, 7, 8, 9. This is 2 over 9. U to the 9 over 2. And plus C. Now, please tell them your C is a real number, Ken. So we are almost there. All we need to do is to put back our substitution. Those who are doing by parts, is the answer very far away? Far away, huh? Yeah, because the exam report also used by parts. Let's see the exam report, the one to do by parts. Now the second one. The second one look very difficult. Huh? It's not difficult. E to the x over e to the 2x minus 1 dx. Okay, method. What would you do? What would you do? Apart from giving up, what would you do? Try lah. In exam, just try. Okay, the integration question, the tough part is they never tell you what technique to use. If you try in 1-2 minutes, cannot, just put the question one side first. Go and complete the rest. Okay? Because this is not something you should struggle and spend 30 minutes. You spend 30 minutes, you don't need to do the rest of the paper already. Okay? So just 1-2 minutes, you try. Can substitute, can work or not. By part, can work or not. Just try. Then after that, try if it's fraction, right? You try partial fraction, can work or not. Cannot work, then put one side already lah. Can? Okay, just like that first. Don't must conquer the integration. No need to conquer anything one. Do whatever you can. Okay, first of all, let me rewrite this to this first. Okay, then you'll see what's my plan. I'm going to do a substitution. E to the x dx. So my dx is 1 over e to the x du. Okay, let's put everything in. This one keep there, no need to remove. This one change. Multiply by this. And then you can remove. And you will get something nice. Can? Technique now. Come, technique. What to do now? What do we do now? The rest. What do we do now? You only got 3 choices. Substitute done already. Already substitute 2 times already by part. You don't want this one can by part or not? Can by part or not this one? I advise not to lah. By part must product. Okay, so left with one partial fraction lah. So how to see the partial fraction? Because the denominator is a square minus b square. So there, a square minus b square get u plus 1, u minus 1. Okay? Sure, we'll do all this one. Okay, so now you just can tell them that, oh, this one I can rewrite it to this. Plus. Okay, wow. Okay, this looks rubbish. Okay, sorry. So I leave it to you to go and find your A and B using your own method. Either you cover up rule or you do whatever method to find the A and B, okay? So the A and B, ayah. Okay, no good. Okay, never mind. So after you have done, you should get something like this. Sorry, this minus 1, u plus 1, and plus u minus 1. Okay, so you're going to do your cover up rule. From here to here, either you cover up rule or you do your partial fractions method to go and find the A and B. Either way, partial fraction method. Okay. Okay, the integral is ready already. We can integrate. Sorry, wait. Okay, I use K because C used already. So I just put K. So let's return the substitution. Now you want to simplify, you expand is okay. If not, just leave it like that. Also fine. Okay, I want to do something. Let's do something now. So this, suppose you do, and you get, let's see, we get something like this. Okay, come you integrate this. Integrate this. I see what you're doing. I'm trying to make the common mistake you all make. Because in the prelims, a lot of people make mistakes. Trying to make you all make a common mistake. Because we have been always integrating a very nice u plus 1 u minus 1. So one of the mistakes that will appear, right? Because I walked one round already, got two mistakes already. What most of you will do is you will do this. Okay, I won't say most of you lah, because I also make this mistake regularly. You'll just end up like that. We'll just end up like that, which this is wrong. Why? Because We need to divide by -2. We need to divide by -1. Can I? Just remember this mistake, because a lot of times we are always integrating this, and the examiner is nice. They always give us this. Then if the thing is switch around, right, or you have some constant there, you usually not aware of it. Then you forget to divide by the -2. Then here must divide by -1. Okay, huh? So this common mistake, this one very common. You take logarithm must remember, because I make this mistake also very often. I also forget. Okay, we still have one more question, right? How many? Which one? Question 2. Actually, question two is easy. Can I? So come, let's move on to question 2. This is the last question, right? Correct. Last one, no? I think should be all done already. Okay, so it says we have a demand function where you have all this. Okay, then we have to form the system of equation. Second, then we have to use a matrix method to solve the system. Okay, so you need to substitute when P equals to 1, demand is 20, then P equals to 2, demand is 14, P equals to 3, demand is 8. So this one, I will just write down the system for you, okay? Back home, you just go and simplify yourself. So when P equals to 1, then you get A plus B plus C equals to 20. Then when P equals to 2, you should get A plus 2B plus 8C equals to 28. So these are the 3 equations that you need. A plus 3B plus 27C equals to 24. So there are 3 equations, these 3. So set up the system. So you get 1, 1, 1, 1, 2, 8, 1, 3, 27, then ABC equals to, 20, 28, 24. Okay, let me solve this quickly for you. The augmented matrix. Okay, let's start the row operation. So R2 minus R1, R3 minus R1. Okay. 0, 0, 1, 7. Okay, I have answer. I don't usually do this fast because I'm looking at my answer. Then one more step is to just get this to 0. Now, you must remember, you cannot subtract a row by any constant. You cannot like R2 minus 1, R2 minus 4 kind of thing, cannot. But you must take one row, subtract another row. Yes, that's why this is called row operations. Not taking row, subtract number. It's row, subtract row, okay? So the last one, this is R3 minus 2R2. Get this. This one you should get 0, 0, 12 minus 12. Okay, so then using backward substitution. Now C is equals to -1. If you work it out, you get C equals -1, B equals 15, and then A equals to 6. Okay, so these are the three. So we managed to finish the paper, right? Correct? All done already, right? The questions?